Hi guys, this is Tobias, DL3MHT, with the long overdue power supply noise comparison. So again, I have my switching power supply here set to 13.8 volt, and this time I have my Rigol connected directly to the DC output of the power supply. And the interesting bit is we are not DC coupling to see the 13.8 volt, we are AC coupling. So the DC offset is disappearing, and we want to see the AC or the HF noise that sits on top of the DC output. So when we put some load on the switching power supply, I would expect that we see some switching noise there. And the interesting bit is, of course, how big is it and is it a problem or not? Unfortunately, I can only do this test with two 100 watt resistors. I have a 10 ohm 100 watt resistor that I set up just by looking at the amperage so that it draws 5 amps. And then I have a 1 ohm 100 watt resistor, and when you directly connect that, it draws about 13 to 14 amp out of the power supply. So I cannot really test the real use case where we are transmitting 100 watt and pull, I don't know, 20, 22, 25 amps out of the power supply. Because when I tried that with my TS50 transmitting into a dummy load, I immediately picked up the TX frequency with the scope. So the scope being just half a meter away from the transceiver and just having here half a centimeter of bare wire, non-shielded wire to connect the scope probe to the power supply output. That was more than enough to pick up my, I don't know, 14.2 megahertz transmit frequency. So these 100 watt resistors are a compromise, but it might give us a first indication how bad the problem is. What I also cannot tell you if it scales linearly. So I'll show you what the noise is when I draw 5 amps, when I draw these 13, 14 amps, but I of course don't know if it scales linearly when we would draw 20 or 25 amps. Okay, enough talk. That was already 2 minute 30 introduction. So here we have the 10 ohm resistor. Let me connect that so that we are drawing about 5 amps. Here you can see it. And I'm pressing single shot and hope that it triggers at some point. It does, because then I can immediately disconnect again and avoid heating up my resistor even more. So with this dumb quick test, I've got about 34.4 millivolt HF noise riding on top of the DC output. And now as a comparison, I'm hooking up the 1 ohm resistor, and well, we are pulling more power, and I would expect we're getting more noise. So again, run it, connect it, pulling 13.5 amps, single shot, disconnect, and I think you can already see from looking at the display compared to before, our noise is now higher. We now see here 47.2 millivolt peak. And another interesting thing to know is I'm AC coupled here with the 20 megahertz bandwidth limit, and I think that's fair because your transceiver probably would not let all HF on the DC line through. There are most likely a few filter caps and maybe even a LC network at the input to get rid of any dirt. So I think setting this up to a 20 megahertz bandwidth limit is fair. And yeah, what we have already seen is with 5 amps we have less noise than when I'm pulling here 13, 14 amps. And the question is, of course, how much bigger would the noise be when I would pull 20 or 25 amps out of the power supply? I guess it would be, again, slightly bigger. I don't know, maybe 60, 70 millivolt. The experts can put some comments below what would be expected on a halfway modern switching power supply. Another interesting bit that I discovered is that the shape of the HF noise pretty much depends on the output voltage. So as we saw just now, I was always set to 13.8 volt, and I tweaked the resistors that I once pulled 5 and once 13 or 14 amps. But when I, for example, change the voltage and say, okay, let's say what happens when we only set it to 9 volt, and then we set the resistor that we pull again 5 amps. I have to manually do this now, so we are a bit too low. Let me just crank it up here until we are at 9 volt, 5 amps. And getting closer, a little bit more. Yep, maybe like this. Single shot. And as you can see, the shape of the HF noise looks completely different to what we got when the voltage was set to 13.8 volt, 5 amps. So that's also, I think, interesting and probably expected observation. So that was the switching power supply. Now let me get the big linear brick again on the desk and we have a look there, but I can already tell you it's not as exciting as the switching one. So back in a second. Okay, and here we are back with the linear power supply, and one interesting thing that you can see here is when no load whatsoever is connected, you get this strange sawtooth pattern on the output. I don't know where that comes from. Maybe it's the linear regulator slightly oscillating when there's no load on the output. It says here the VPP is about 50 millivolt here at the moment. But as soon as the load is connected, it completely collapses and disappears. So this is, well, it's an interesting observation, but nothing to worry about. And again, I have my 10 ohm resistor set up so that it draws 5 amps out of 13.8 volt. I mean, you can just calculate the resistor value. R equals U divided by I. So 13.8 volt divided by 5 amps gives you 2.76 ohms. So I guess the resistor is somehow set up close to 2.76 ohms now. And when I connect the rotator here in the middle, you see I'm pulling 5 amps. The sawtooth noise has completely disappeared, and let me take a single shot and show you how bad it is. We're seeing something like 26.4, okay, let's say 27 millivolt right now on the output. So in comparison, let's hook up the 1 ohm resistor and see if that dirty noise gets better or worse. So again, connecting it, run it, and hook it up. As you can see here, we are pulling 13.1 amps at the moment. Single shot. Disconnect again because, yep, this thing, the 100 watt resistor gets nice and toasty when I'm pulling 130, 140 watts out of it. And the VPP is showing us 29.6, so let's see, say 30 millivolt peak. So not a big difference compared to pulling 5 amps. And yeah, I tried to zoom in here a bit, and I don't know what I'm really seeing here. If you really zoom in, you get with a resolution of 10 millivolt per division, you get a little bit of a spike here that shows up regularly. I cannot see the correct frequency of that one, and I don't know where it comes from. It's definitely not a 50 ohms hum, so maybe it's something that it picks up from my AC voltage line. I'm not sure. If anybody knows, what this bit is and where it comes from, please put it down in the comments. Okay, so this was the comparison. Switching power supply, well, my cheap Amazon switching power supply with my equally cheap Amazon linear power supply. This is how it looks like. So let me know if I should do a third installment of this video where we open up the case and have a look inside of the two power supplies, just looking at the components. And yeah, I probably can only give a rudimentary description of what we see here, but maybe interesting as well. So if you want to see that, let me know and I'll do it. So thanks for watching for the moment, and until next time. 73 from me, and as you have seen, the cat is also here in the shack demanding attention, so that's what I will do now. Give her some extra pets. Thank you, bye!